This is C4, section 18, parametric equations and integration. We're on page 45 of the C4 note booklet. As usual, I will need you to pause it to take notes. I won't be pausing myself as I would do as part of a lesson, so you will need to do that for yourself. So basically, integration parametric equations, we need to replace the dx with dx by the dt, or whichever letter that we're using as our parameter, so it could be theta instead, for example. So this is very similar to integration by substitution. So here we have an example where we've got a curve given parametrically by x equals tan t, y equals sine t. We've got an area defined between t equals pi over 6 and t equals pi over 3. And we want to find the area and the volume. We're told what the integral should look like, but we also need to evaluate it. So we've got to show that question so we know where we're heading to. And then after that, we'll know we've got it right that far. Now to do the area under a curve, it's the area between the x values of y dx. Now we don't have the x values, we have t values instead. So because we're in terms of x, we would write t equals for the limit. So from t equals pi over 6 to t equals pi over 3 of y is equal to sine t dx. Now here we need to replace the dx in terms of the t. So from the question we have x equals tan t, so we differentiate dx by the t is sec squared t. So dx is sec squared t dt, so we can input that into our integral. So we get the integral of sine t times sec squared t dt. Now we want to get the integral of tan t times sec t dt, so we need to do some rearrangement. So sec squared is 1 over cos squared. I want to keep one of the sec t's, so I'm going to have sine t over cos t, because one sec t is what. Sec t is 1 over cos t times sec t dt. Sine over cos is tan from C2. And we get the integral of tan t times sec t dt. So that is the integral we've been asked to show that the area is equal to in the question. Now this is a case where you can look up in the formula booklet for C3, you should know that sec t differentiates to tan t sec t. So it integrates, tan t sec t integrates back to sec t. So put in the limits in, sec of pi over 3 minus sec of pi over 6. Calculates, remember that's on a calculator it's 1 over cos pi over 3 minus 1 over cos pi over 6. Excuse me. Make sure you've got calculator radians. So the first one is equal to 2. And the second bit is 2 root 3 over 3. So the answer to the area is 2 minus 2 root 3 over 3. And that gives us the area. Right, similar sort of idea for the volume. for the volume, it's pi times the integral. Again, same limits, but in terms of t. Of y squared, so y squared in this case would be sine squared t, but dx at the moment, the working that we did for the area gives us dx in terms of the t, so we can substitute that in. So we get the integral of pi times sine squared t sec squared t dt. We're supposed to show that's equal to tan squared. Sec squared is 1 over cos squared, so we've got pi, the integral pi over 6 and pi over 3 of sine squared t over cos squared t dt, and that that is equivalent to tan squared t dt, and then that's a standard integral to work out using trigonometric identities. So tan squared t is equal to sec squared t minus 1. We're using the identity 1 plus tan squared t is equal to sec squared t. Integrating, sec squared integrates to tan, 1 to t, same limits as before. Don't forget the pi at the front. So we've got tan pi over 3 minus pi over 3, take away. Make sure you've got all the brackets in. Tan pi over 6 minus pi over 6 equals pi, open bracket, and if we just look at the tans, tan pi over 3 minus tan pi over 6 is 2 root 3 over 3. Minus pi over 3 minus pi over 6 gives minus pi over 6. And that's an exact answer. If we're asked for a particular form, you may have to do more rearranging than that, but it's an exact answer and we can stop there. And that concludes this session.